Welcome to the CIO Evolution. In this podcast, we'll explore the Chief Information Officer's role in executing a new ongoing leadership imperative, digital transformation that promotes agility and resilience. How do CIOs upgrade legacy networks? What are the financial challenges CIOs face? And what are the security measures that are required in the new work from anywhere, mobile and cloud-based world?
Hello, and thank you all for joining me for another episode of the CIO Evolution, coming to you from RSA Conference 2023. I'm your host, Chris Jablonski, Director, CXO Revolutionaries and Community. Today, tucked away from the bustling halls of RSA, I'm joined by Nathan Howe, VP of Emerging Technology at Zscaler. Nathan is here to talk about recent collaboration between Zscaler and one of the world's leading manufacturers of semiconductors, Intel Corporation. Nathan, thanks for being here.
Chris, always a pleasure.
All right, so there's this press release and discussion around the three-way partnership between Intel, CrowdStrike, and Zscaler. And as a part of that release, there's discussion of the security, access service, edge, connectivity, acceleration. So what that means is to address the scale of remote user access to a cloud resource via SASE point of presence. The companies essentially have come together to optimize SASE components with Intel Xeon scalable processors and accelerators, such as Intel Quick Assist technology. So there's a lot of technical detail in the press release, but to get started, can you give us a 30,000-foot view of the collaboration that was announced this week at RSA?
Yeah, absolutely. And yeah, it's not a really easily readable press release. It's very technical, and that's why I guess people like me, nerds like me, like it. In short and sweet, the best way to think of this is that we're working together to further optimize what we do. Zscaler doing better things, CrowdStrike doing better things, and Intel doing better things. And what that means technically here is that CrowdStrike is able to now be more informed by integrating with a lot of the new threat intelligent detection that Intel is building into its chipsets. So CrowdStrike can actually pull more information in, therefore be more informed. Likewise, Zscaler is partnering with CrowdStrike on the threat intelligence, so we're actually able to consume and share information with them. So obviously when we see a threat, we're able to now identify it in a much more optimized way, but also in a much larger way. So we're actually able to look into the things that are addressing the security threats that are much further down the stack, not just application level, things we may see that actually impact the chipsets and other things. But the goal of this then is also then to have an output of that. And that output is a control, a command, a block, an allow, isolate. And that's where Zscaler's SASE platform, our Zero Trust Exchange, actually provides the control based upon the learnings of this Intel, CrowdStrike, Zscaler platform. And the output ultimately gets enhanced by Zscaler running our platform, our Zero Trust Exchange, on this Intel infrastructure and taking advantage of things like the Quick Assist.
So buried in the press release are terms like accelerating SASE connectivity, reducing latency. So it seems like speed and transparency and overall optimization of the user experience is part of the value here. So does that mean that without using Intel or anything similar, we are losing out on potentially vast gains?
It's not to isolate that doing this solely with Intel is better than others. Of course, we're using new technologies to improve the ways of working. But we're also intentionally making ourselves available to our older ways of working and where our customers need us. So Zscaler operates and functions inside of x86 architecture from Intel, but also is able to operate in other places like ARM. Now, we can't always extract the same sort of modern security information that we're able to get from Intel in the current and the modern chipsets, but that doesn't mean we can't run. It's just a matter of what else can we achieve with the new thing. So it's like adding a rear wing to your Formula One car. It gives you a bit more downforce so you can go faster. It's still a fast car, but now you have a little bit more that you didn't have before. So you get from point A to point B a little bit better, in this case, a little bit more secure.
Is there any company that is very much keen on using this capability, or maybe certain industries that this could serve best initially?
I think it's more about where it will be built into rather than a specific industry. And we'll see this probably in partners like we deal with hardware partners like Supermicro, who are delivering the overall technical stack to an SD-WAN provider, a Edge x86 box provider. So that's where you'll see the insights coming through. So people like, when you buy the new solution, it'll be built in and we'll take advantage of it. That's not to say that the older services are not going to work. It's just that those new advantages that we pull in from CrowdStrike, from their integration into the Intel chipsets, that we won't necessarily have those, but that just means we have to look for other intelligence elsewhere.
Got it. So what we're talking about is adding capabilities and efficiencies at the core of the platform that could then span out horizontally to anybody, right?
Yeah, exactly.
So digging a bit deeper, I see words like confidential computing and hardware-assisted security. Let's unpack some of those terms. So, for example, hardware-assisted security, we at Zscaler don't necessarily use that every day, right? Can you help us understand how hardware can assist software security vendors like Zscaler?
Yeah, and this is actually a really fun conversation. You need to think about this not necessarily just around Intel, but really any opportunity to optimize a process. And you can think about this if you have a modern computer today, like a laptop from Apple, they have a chipset in there that optimizes the way in which you do video for your FaceTime call, so it looks better. It's done in the chipset rather than software. So they create dedicated software on a chip, basically to deliver those functions. And this is no different here. So what we're saying and what Intel's able to do is able to give us things like improved performance for TLS, SSL decryption, or we see this within larger environments where we need to have optimized operations. And of course, if you are able to offload those optimized operations from the generic CPU and onto a chipset, you get advantages of that. So that becomes a benefit. Again, not always going to be necessary depending on the use case, but something that is a good thing to have where you can use it. So things like the Quick Assist from Intel will allow us to do faster operations where it's possible without having to be heavily leveraging the CPU. We can hand off to those things. And that's where the advantages of hardware acceleration or hardware, let's say, advantages come into play. But it requires also the hardware being aware of what's going on. And this is where we have to have a standard, like a TLS, SSL, decryption mindset. You can't just build random chips to do different things. That's called a processor, CPU. These are dedicated hardware resources that are available to make things more effective. And ultimately, that's what it comes down to, is offloading things that can be optimized to make it much better and quicker.
Got it. So an analogy would be a graphics card in a computer dedicated just for the display.
Yeah, exactly. That's a great one. Though I do find the H.264 decryption. Codec, for video, which is basically now built into every device to accelerate video. So putting all the heavy load, and actually, to be honest, it's also power efficient. If I think about it, as you're not putting everything on the CPU. It's more of that we're building more optimized architectures for use cases. And that's why, to come back to Apple again, that's what they've done with their M1, M2s, that the entire idea is to be more optimized and not have everything in one big solution. Now, I know that's not the same as Intel, and we're talking about Intel today, but it's a good example of a customized environment that only works specifically for Apple. It doesn't work for other providers. Whereas Intel, in this situation, and the press release, they're discussing the ability to actually get not only faster security activities, because they've built the abilities like Quick Assist to actually do encrypt and decrypt of SSL TLS, but also provide insights to common things. So if we see a threat that is known to be a certain way, execute a certain way, well, the chipset identifies that rather than relying on sending the code to the processor runs it in a different way. These optimizations, especially as we become more standardized in the security world, will be better, but also this will help things as we get to the needs for very heavy data set utilizations, which is all the buzzwords right now with your large language models and so forth.
Okay, we might get to that in a bit here. In terms of the intersection between some of the capabilities that Zscaler has, such as with dynamic policy enforcement, there's so many inputs that go into these split-second decisions, as you go back and forth in our inline security processing, right? So can you talk a little bit more about, if it's not just the speed, is there any gains made that are maybe not primary, but secondary in terms of that efficiency or benefit?
Yeah, I think that the one that probably strikes me the most is if you look at a true risk-based policy engine, which is what Zscaler has built, is that if I'm, and let's use myself as an example, if I'm browsing a malicious website, I should not, in my very next session, be able to go to an SAP ERP platform. So my activities should absolutely, that are happening now, should affect my actual next activity. And that is the goal of being risk-based. And in order to do that, we have to have very, very, very quick mechanisms to make decisions that are not only assessing what we're doing in the real time, but also then instructing the next action. And that's kind of where we're getting to a point of with Zscaler is by having another optimization. And of course, we're always looking to deliver more optimizations to make this more effective. The more we have, the better. And that's exactly what we're seeing with this. So that's a really good example of how we can utilize the knowledge gained to make more intelligent decisions. And the more intelligent decisions we can make, the more secure things are, and the simpler it is for users to roll out policies rather than having to go and build hundreds, thousands of manual rules.
All right, let's shift gears a little bit. So Intel is also planning on releasing its own zero trust reference architecture at RSA, which we of course contributed to. Can you describe the process of collaborating to draw up that document and maybe share some of its core tenets and maybe how that might look different if you're comparing it to just our own zero trust architecture documentation, which you're definitely familiar with as you've been producing them.
I think the key thing here is that zero trust, if you look at it, and I think the commonalities, if you will, across any key documentations and white papers from various organizations like NIST or CISA, and even from us from Zscaler, the key is to ensure that nothing happens without authorization and approval. So that's the thing. Then you can't get access to anything. You're not allowed to see an application. Now, in the Zscaler world, we talk about it at a high level of like the layer 7, if you will. And if you look in the OSI model, we're talking about the applications and probably layer 4 through the layer 7. We can't connect to an application, can't see the IP address, can't resolve it, can't do any of those things until we go through the chain of approval, authorization, and then enablement of access. Same goes with Intel, and their design is actually a little bit lower though. They're talking about getting into the actual zero trust design of a chipset. So should actions occur inside a operation environment with just random abode, it should actually be more, of course, the secure drive or zero trust drive of let's not deliver things without going through and understanding the authorization of that command. Now, that's very difficult because a CPU or a chip by nature has to have each one of its transistors being on or off. Now, deciding which one of those are being used becomes, again, building those hardware optimizations in. So, and this comes down even into that trusted compute direction we've been hearing about for years and seeing in some places. But the idea that certain data sets that are flagged get processed by certain parts of the CPU and only in a certain location is already a zero trust direction. It's just much more granular, and it's a very pragmatic but static way of doing it. And what we're saying with Intel and we're seeing with their direction is we need to be more informed to make, as we're just discussing, those dynamic decisions, because the static nature is great for a point, but as we find out, we need to move forward with new things. There are new threats, new technologies that we have to incorporate to make those decisions. So getting into those kind of programmable decisions within a chipset, those sort of services like field programmable arrays have been around for a long time, but doing it in context of a dynamic communication flow is actually really, really interesting. So that's where I think Intel is going to really achieve a lot with their zero trust kind of framework and architecture, but it's very much focused on that lower level. Not that there's anything wrong with that. It's just it's applying the same exact mindset that we have at Zscaler around zero trust, but doing it in a way that is actually executing at a lower level, and then we can take advantage of that, of course. But it's nothing happens without being authorized under the appropriate conditions, the appropriate context, and then applying the controls you need to based upon that verification and authorization.
Right. Sounds like ever faster, split-second automation to ensure the policies, the governance, and the right decisions are made, right?
Yeah, and that becomes even easier now. To just elaborate very briefly on that is because hardware is becoming exponentially powerful. We can do so much more on a chip than we could ever do. And now the software is lagging behind, if you will. Like software can't run as fast, it can run as fast as it wants, but the chips today are just outpacing it. And we're being smarter. As I said, we're taking functions off, building individual chips for it to make things faster. So that idea of optimization is always going to drive this industry.
Just a quick curveball. So we know that Moore's law is starting to flatten out, and quantum computing is around the corner.
Yeah.
So you're no longer going to have ones and zeros, but superpositions. I suppose that'll have to rewrite the entire architecture.
I mean, it's interesting because a superposition is based on the idea that something exists and doesn't exist at the same time. So that in itself becomes a whole different way of thinking about trust, and especially in a zero trust world. If that qubit both exists and doesn't exist, hold on a second. How do we actually understand it? How can we calculate that? So yeah, I'd say there's an evolution. Maybe it's going to be like to use the Apple computer as an example again. Maybe there'll be like a Rosetta program or even like the original Rosetta Stone for the good old fashioned compute world to quantum compute. That'd be fun to see.
Well, we'll save that topic for a future episode on the horizon. But back to the world of the concrete. One question that I have around this announcement and everything that you've been talking about is whether or not, when in practice, we have this inherent agnosticity around which network you're on, geography, how many apps you have in the cloud, whether you're multi-cloud, hybrid, the device landscape that your entire employee population is using, whether it's BYOD or corporate issued. Do all those things impact the performance that we're talking about, or is this really agnostic of all that, and it should all work pretty much the same regardless of network you're on, whether it's 5G, SD-WAN, et cetera, et cetera?
A network will always be constrained by its throughput abilities, how much you can actually put through it. And yes, like 5G's fast, 6G will be faster, et cetera. But what we're saying here with these controls, we're not constraining the throughput based upon these controls. These are just the sets of controls that are conditionally making a decision about whether that throughput happens or not. So yeah, ideally and of course you can always argue though, and this is a fun discussion to have with many a company is, by nature, a packet running through a network is going to run at line speed. The moment you put a control in front of it, there is going to be some level of latency. It's the nature of compute. You've gone from being a very simple binary command flying across a wire that now has to go through another path to have it assessed. Now, that latency is obviously minimized by the levels of technologies and so forth. But that trade-off of whether you're willing to have latency versus whether you need to control something needs to be balanced out. What we try and do at Zscaler is ensure that there is minimal latency when we're connecting, and of course that's why we have our distributed mindset of our edges. But as per the announcement with Intel, there's the ability for us to run our edges anywhere. Yes, we deliver those in 150, 160 locations for our customers. That's we run them, we give them to you, you use them. But there's no reason why we can't add more and move them into other locations. You can run an edge wherever you need it to be. And most of our customers are starting to see this, and that's the whole idea of edge compute is clearly becoming very, very apparent to everybody. Well, Zscaler is just a control layer. You run your edge compute. You bring the control closer, so you minimize the latency of the network. And a great example I always love to use about this to help paint the picture is, as the Australian living in Germany, I can't easily see Australian rugby because I can't stream that. There's just no there's a geo boundary, other things I can't use. So Zscaler, I use Zscaler to go to Australia and view the games and watch them. That's great. But it doesn't matter how much I apply the control to send the traffic back and forth to Australia, I'll never break the 16,000 kilometers of latency. You'll never break the speed of light, regardless of what we're trying to do. So yes, we can optimize. Yes, we can move some packets around. That's why we have CDNs and so forth. But again, there are certain things that are always going to be limited, always going to put limits in place. And the moment you put a control, you'll have to consider what the control will have an impact on. But then you have companies like Zscaler who are always optimizing to try and make that level of control latency go away. So yeah, the network question is does it impact it? No, I mean, all these bits of information are conditionally consumed, but then when the control is implemented, it needs to be decided, and where, and more importantly, is how you can minimize those kind of impacts.
And there's an inevitable trade-off with maybe some latency, right, to get that security control in place.
Absolutely.
All right. Well, Nathan, we're coming to a close here. You've been at RSA for a couple days. What are your thoughts in general? I think a lot of vendors had to rewrite some of their talk tracks to embed commentary on AI and LLM and all the things that we're seeing there. But whether it's AI or anything else, any thoughts on where this event will go down in terms of how people remember it?
I think everybody's happy to be back at a real big event. That's clear. And then look, it's fun. Don't get me wrong. It's a lot of fun to be out there and talk to contemporaries and peers and partners around things. But I look at messaging. I don't think that there's been a lot of news around AI. Yes, there's been some press releases, but I think that's just going to be next year. But having said that, one of my things that I find very interesting, and I guess as a company that's been coming to RSA for a very long time now, it's just really funny to see that the messaging is all becoming, let's just say, very much cloned. We see the same thing across different booths, and it's dressed up differently in different ways. But it's a very similar message now, and it's everything is get it to the cloud. Everything is optimization. Everything is zero trust. Everything is SSE. And it's great to be in a situation where we can smile and admire that the industry is moving in that direction, given that we've been so involved in that for the last 15 years. The other thing I will say is the venue and the whole event has been fantastically run, but there's a lot of, I guess you can say, the interconnectivity of just meeting people in this scale and actually having the conversations. It does. I think everyone missed that, and everyone talks about getting back from COVID and whatever else. But I think having the face-to-face communication and actually doing it in an event where there's so many people around just adds a certain spark to it. It's like going to a concert versus sitting at home listening to music. There's something more to it. So that's been good. But I think next year we'll have one big unified message. Everyone's going to have AI labels slapped on their stand, and we'll hear about all the fantastic AI things that are happening in security. It's going to be a big 12 months, that's for sure.
Absolutely. We've been speaking with Nathan Howe, Vice President of Emerging Technology at Zscaler. Nathan, thanks for making the time to talk to us on the CIO Evolution.
Thank you, Chris.
Thanks for listening to the CIO Evolution. Check back with your podcast provider regularly for more episodes. You can find more episodes along with other podcasts on the CXO Revolutionaries website at revolutionaries.zscaler.com. Statements by Zscaler podcasters and guests are informational only and should never be construed as legal advice. You should consult your legal advisor on matters related to you or your business. Zscaler makes no warranties, express, implied, or statutory as to the content of this podcast, and it is provided as is. Content on this podcast may contain forward-looking statements that are current as of the date of the recording and subject to change. These statements are subject to the safe harbor provisions created by the Private Securities Litigation Reform Act of 1995. Full legal disclaimers are available at revolutionaries.zscaler.com. Copyright 2021.